organize a seminar titled Mapping for Impact, Unleash Spatial Stories that Drive Change. So initially, the idea for this seminar was to discuss how combining spatial data with critical analysis can drive changes related to environmental challenges and reveal actionable insights for decision makers. So our invited speaker for today will guide you through the ways we can use current technologies to create impactful data-driven visual narratives and how to use mapping to share a story. Throughout history, maps have been used to assert control, tell stories, shape perceptions of the globe. They traditionally convey information, they illuminate patterns and trends across nations, regions, neighborhoods, or even specific sites. They can transcend visual representations of geographical locations by embodying cultural, historical, and even emotional dimensions in some cases. And beyond their function as navigational tools, maps can depict political boundaries, population distributions, climate variations, and even more abstract concepts such as memory, migration, or power dynamics. In this way, maps can serve as both practical guides and profound narratives and shape our understanding of space, identity, and human experience. For this specific seminar, we will focus on environmental data in a way to enhance climate adaptation efforts across very diverse communities. We will do that through the use of mapping. We use the mapping as a tool that could influence socio-spatial and environmental decisions. So I would say that in brainstorming who to invite for this specific seminar, I learned more about the work of the speaker, who is utilizing tools and methods for mapping. And I got familiar with his work through his YouTube channel. It's Miloš Makes Maps, where he empowers geospatial professionals and also curious beginners to start with mapping with R. R is basically, for those that are not familiar, it's a programming language to create maps that make sense of big data, transforming raw data into visualizations that can drive real change, real world change. So thank you so much, Miloš, for being today with us. We're really glad to have you, and you can discuss about your projects, your methods, the tools that you use to reveal the spatial inequality on environmental data shifts, urban sprawl. You can explain how your analysis can inform smarter urban planning decisions. So I will stop here and I will give you, the floor is to you. You can start sharing.
Thank you, Eleni. Well, first of all, thank you for a warm welcome, and thanks everyone for joining today's talk. I was thinking before this seminar, what would be the best way to, what would be the best title for this presentation, given that I really wanted to show my whole a roadmap, so to say, from my thinking process, from the ideas to the actual data, and then the map creation, and then how I put this into practice. So I actually came up with this very long title. Before actually I started mapping, so I just wanted to kind of briefly talk about this. So how I actually ended up mapping, and why do I use R actually? Why R? Why not something else? So I actually used to work in academia. So I have a PhD in political science. In political science, it's kind of a split. Most people do qualitative science or data science. It's mostly in Europe. In the US, I would say there are way more who do quantitative. But I try to kind of marry both worlds. And in that process, I was kind of first using Stata a long time ago. But I had one colleague who actually told me that, asked me actually, why are you using Stata? It's so limited. I said, yeah, you're right. What should I do? And he said, hey, here is R. It's like a programming language. You can actually customize things, you can write code and create so many awesome things. But my beginnings with R were quite frustrating. It's a very difficult programming language. I'm not going to lie to you. It's super difficult. I would say that Python is also very difficult. Any coding language is difficult because you're essentially learning a different language. And it was, at many points I wanted to quit and not to use R anymore, but it's just, I guess I have a lot of curiosity and I wanted to push the boundaries and to kind of really discover what R can do, especially after seeing what other people have done. So I started actually with creating some, bar plots and graphs, and that was kind of very basic in the beginning. But over time, I started doing more complex stuff, also running some models and trying to, depict those statistical models. And at some point, I also worked for one think tank in Belgrade. And there was a need to create a map. So that's where I started kind of creating a bit of maps as well with R. And then I discovered, actually, I really like this. So I want to continue creating maps. And I started creating some very simple maps, but over time I got exposed to more data types, to more, different ways to acquire data. And here's what I actually want to present today, how kind of having all this in mind, what kind of would I suggest to you today? What would be kind of my roadmap from coming up with an idea to creating a map, and then to using maybe this map for some policy, to influence the policy. So first things first, how do you start your mapping project? So I would say the same way you would start your academic project as well. So you would explore probably some, existing articles in academic journals, maybe some kind of reports that exist out there, someone has published about some topic. Maybe you find something interested on social media. And to be honest, mostly how I come up with ideas is browsing through social media. So I started, using Twitter more than 10 years ago, I would say like 12 years ago. And over there, you have a lot of other people posting interesting questions. And then you think, maybe I could map this. But that's how I started thinking, maybe I could map this. This is an interesting topic. Maybe I can map. Is there data on this? Then came some other social media, most recently Blue Sky, which is kind of a competitor to former Twitter, which is now X. And there was a competition at some point on Twitter where it's called this one, 30-day map challenge, where people started to make maps based on some kind of challenges for some topics. And that was also interesting to learn from others what they create and how they create and what kind of maps I could also create and what kind of data I could use. I also enlisted here some YouTube creators, if you're interested to take a look. Some of those creators are really inspiring, excluding myself here. I'm going to exclude myself, but all these others are super inspiring because they use different tools, because some of them really can create powerful maps using data in a very simple way. And I would warmly recommend, especially John Nelson maps. This guy, he's using actually an app, which is a drag and drop app. So you don't need to have any coding knowledge. It's very useful. MathForest also covers a QGIS tutorial. So I would say that that's also very useful. This is more Python battleground, open geospatial solutions, and my channel is more about R. So these two, if you really want to dig into programming languages and to use coding actually to create maps. And then last but not least, more and more we have also the generative AI and chatbots and talking with chatbots to understand what are the potential topics. So I also use a lot of ChatGPT for that purpose. It really helps to search. I use it more like I would say a search engine. Search the online database, tell me like what is out there, maybe suggest me some data sources. And I think this is just more like a general question we can maybe discuss later. What is that motivates your research? How do you come up with ideas? Are there any of these things that I listed here that are also a source of inspiration for you? Or maybe there's something I didn't mention here. Of course, there's a lot of interaction with other users on social media. So this also, I would say, a source of inspiration for me. So a lot of people approaching me on YouTube or on X or on Blue Sky asking, hey, can you maybe cover this topic? So what usually comes up is, for example, how do I map population? What is the best way to do that? What kind of maps would you suggest? How do I show urban density? How do I calculate, this or that? Then there's also huge interest in, for example, land cover and land use data, which is basically what is on planet Earth that we can recognize as certain feature, whether it's urban area, maybe water, forest, grassland, something like that. Of course, sometimes questions become super complex. People asking, hey, can you actually prepare a tutorial on predicting land cover classes? And I think to myself, if they only knew, I come from political science, I really don't, sometimes I don't know, something specific like that. There are also a lot of questions about very important climate, of course, temperature anomaly, precipitation, this kind of stuff. Pretty, useful questions. Again, they can become also very complex. People really asking something from their specific domain, and then it becomes very difficult to to help. How do you calculate something? How do you map when it's so specific? And then finally, I think this is from my own area, the international studies. Yeah, conflict zones, social unrest, protests. How do you map that? What is the best data for that? Yeah, those are some of the topics that are kind of that I feature also in my videos. That I'm interested in as well, and the questions I get also from other users across social media. Now, when we talk about moving from idea to data, there are actually a lot of questions here. First of all, the main question is what kind of data should I use? And what I usually use is publicly available data. The reason for that is it's easy to gain access to this data, but it's also easy for others to replicate your work. And I really believe that replication is one of the most important things. All these tutorials that I make, they make no value unless someone can replicate, or even better, take the tutorial to some other area and recreate a map for their own specific geographic area of interest. Now, in terms of data sources, I would say there's like several ones. So there are public repositories, so the open government portals, satellite data, maybe featured on some other websites. You maybe are familiar with some of these, but if you're not, that's fine. Some of them are really like domain specific. So this one is European Space Agency. They have, for example, data on land cover, extremely useful for people who are working on land cover. Or MODIS is the satellite data and imagery, Sentinel as well, Sentinel-2. Very valuable for also not just land cover, but also digital elevation models for terrain, also creating calculations for climate data, environment, so many different use cases. And of course, there are some initiatives or sources of data which are just community-led, community-contributed. Basically, have institutes or group of people who have their own curated data sets, maybe coming out of their own research and then posting on their websites for free, so you can download this data, or maybe you can use APIs and get there. Now, we come then to the ways to access these data sets. Like the most traditional way is, of course, you go to a website and you download, usually it's either tiles or complete data. That's, I would say, the standard way, the easiest way. For me, still the easiest way. But that's not always the case. Sometimes you also need to register for free and then you can download. A lot of these services, like, for example, NASA or also, I think, European Space Agency and others, you really need to first register for free and then you can start using it. So there's already now like some kind of a wall or I would say a wall to this kind of access to data. It's still open data, but you have an obstacle there. What is more and more kind of popular is this Google Earth Engine, which essentially allows you to go to a service, online service, and then you can leverage Google's compute to analyze, thousands of different data sets curated again from academic sources. And you cannot just not only download from Google Earth Engine, you can also do your own calculations there. You can do mapping. It's a very awesome tool. The only difficulty it is, I think it's written in Java or JavaScript, so you need to know a bit of that. And it's a very difficult programming language, I would say, even more difficult than R. What is actually very important for R and Python and all these other programming languages is that you need to understand how to use APIs. So this is like has become a must, like if you really want to work with the data, because more and more of these different data curators are using essentially API to make their data available. So you need to understand how APIs work and how to communicate with them to get the data you need. Now, the good thing or the good news is that you also have in Python and R a lot of packages that serve as a front end to you. So they have in the backend this API, but they serve as a very user-friendly front end for you. So you can just, with maybe one line of code, get your data in no time without the need to, mess up with the APIs. And how do I call API? Is this call good or not? Did I miss something? So these packages or libraries, they do that for you. So these are all different ways to access data. Again, I really like the more traditional way, so directly just download, unless the data is huge. In that case, doesn't really work for me. And I also like through the packages because then I don't need to worry about, I'm not really a data engineer. So for me, if I can get access to a package or library, that's really great. Okay, so you have your idea, you found the data you want to download, but then there are, again, some challenges with accessing the data. One of them is, of course, not all data is open. So I've been now talking about open data, but open data is a fraction of the data that exists online. A lot of data is not free. So it's owned by companies and they want to charge you for the usage. So in my tutorials, I don't use this data. You could probably use such data, but I think it's just you need to be mindful that for that data, you will be charged and you need to understand what are the terms and conditions of this use. So that's something I would just recommend. The second problem with data is the data quality. So the problem, especially with satellite data, is that the resolution of this data is not always the same. Or if you're moving across data sets that cover the same topic, like for example, forest cover or tree canopy height, it's not always going to be the same resolution. So there's a problem of how do we integrate all these different data types into one. And then oftentimes, as in also social science, there is missing or incomplete data. So what do you do with that? How do you cope with that? Especially with satellite, Landsat, and Sentinel data, that's often a problem because sometimes due to for example, bad weather conditions, they cannot really capture some parts of Earth. Then they need to, again, rotate, that satellite needs to rotate again around the Earth, take again. But what if, again, the weather conditions are not good, and at the same time maybe in that part of the world you have, let's say, floods, and you really want to capture that. So essentially you're missing a very important piece of information because simply the technology could not capture due to the bad weather conditions. So there is problem missing or incomplete data. And then there is a problem of data formats. For example, for the vector data, which is used for like polygons and lines, and usually a way to kind of show country borders, regional borders, so let's say roads. The most standard one is shapefile, but there's also others like GeoJSON. There's also like the GeoPackage format, which is now getting more traction. And a funny thing about shapefile is not really one file. It's actually 4 or 5 files. And if you omit one of these files, you won't be able to use it. So that's also that problem, added complexity, so to say. Similarly, when it comes to the raster data, which is also used a lot, especially when you're working with satellite imagery, the problem there is, there are different also types as well. There's also a volume. So this is what I was talking about before, which is like, you can use direct download. Data is small, like a few megabytes, but oftentimes the files are really huge. So you cannot really just go and download because let's say they're 5 or 10 GBs. You're going to spend, depending on your network speed, you might spend maybe 1 hour downloading. So that's why it's really important that there is a way to kind of crop, use only that small piece of data you really need. And of course, there is a problem of integration and interoperability. So there are many diverse data sources. So in terms of satellite imagery, that adds complexity. So there is Landsat, there is Sentinel-2, there is MODIS, there are local surveys. You need to understand actually how these were collected, how can you use them, and what are the main challenges with those data sets. And finally, there is data harmonization. How do you put everything together, make sure they have the same projection? So there is also that additional complexity. There is a universal, I would say, projection, so WGS84, but there are also local ones. Every country has their own. So you need to also understand how that works, and how can you work with some projection? Is it a metric or is it a degree based? There's a lot of stuff there as well. Also, what is the scale of data? How crisp it is. So these are some of the challenges. Maybe there are even more, but these are the most important ones that I wanted to outline here. So I really suggest using open data whenever you can, and also sharing your data, making your data open data. Why? Several things. First of all, of course, it's free for all. It's open data. You can access whenever you want, how you want, download how much you want. So there is no limit there. There is often a very helpful community support. Usually this data is created by institutes or academic institutions who are more than willing to help that you download this data. And they also continuously work on the new versions of these data sets. There's also flexibility to change this data, remix it for your own use. So there are no, again, limitations there. And of course, what is great about open data, if everyone is using it for academic research, there is also enhanced reproducibility here, collaboration across research projects using the same data. So here I just wanted to outline some essential examples of open data. Here I put actually a link where you can go and download yourself and try these different types. And here I just put a link to one of my videos where I actually use this data. So if you want to try R, if you want to try it out, you can just go and see how this is done in R. So there's a code there, and also in that video, you'll find a description box link to the GitHub repo with the code, so you can try it out. And these are some of the most essential ones. So this is for the country boundaries. This is going to return the vector data. OpenStreetMap, I guess everyone here is familiar with OpenStreetMap data. It's open data. It's used for storing data, local data on roads, points of interest, waterways, yeah, you name it. It's and what is great about OpenStreetMap is that you have contributors from all across the world, and they add data about their own local communities locally to that repo, and then they make it available to everyone across the world to download this data. So the downside is that it's sometimes incomplete for some parts of the world. So that's something to take into account. This one I covered. So this is about the land cover. Natural Earth, you can find here a lot of different data, cultural, physical data on different countries and different localities. This one I like in terms of using for terrain tiles, so digital elevation models. For this one, Sentinel-2 imagery is, yeah, one of the most famous ones. It has different places where you can get this data source. So I didn't really include here a link because there are so many of them, multiple. This is if you want to work with climate data. This is if you want to work with different animal species, tree height, and the world population, which is really an awesome, if you're a social science, you definitely need to try out WorldPop. WorldPop data is essentially raster format. It shows you population density or population accounts based on the disaggregation using the UN data on the sub-state level. And it's very easy to download, so it's not that large, I would say. Now, okay, so we have the data. What are the tools for effective mapping? And I'm going to start with these user-friendly tools because I also use some of them. So, for example, when it comes to mapping, the advantage of these web and desktop platforms is that they are very user-friendly. So literally, it's like click, drag and drop, and click, and that's it. In a few moments, you can really create your own maps. You can modify the existing polygons, for example. You can create some, I would say, very, very good maps. The only problem with for example, these platforms like QGIS, which I sometimes use actually to just gauge the data, or RGS Online, the main problem is that they lack reproducibility because they're not using code. It's mostly like, yeah, someone goes there and then clicks and then creates something. With the code, which is Python and R, which I advocate, is you actually have a code, everyone can access the code, everyone can run it, see if it works, they can modify it, they can reuse it. And also what is important is they can, you can debug together with them if you know what are the packages they use. And over here, I just put a few packages for R and Python that are essential if you're doing GIS and data visualization. Like it's a must have. I think if you ask me like what is better, R or Python, I would say Python is more widely used. Most applications using including the Google Earth Engine are written in Python, I think, or they're at least adjusted for the Python usage. So R has problems there. And Python is constantly involved. It's a very general programming language. So I would say it has an advantage there in general. More people use it. But if I think about the specific libraries, I would say R has more libraries, more packages. It has, from my experience, a way more helpful community. And it has some packages that are really amazing and that Python doesn't have, and that would be this one, RayShader for 3D visualization. And I will show you later how actually this looks like. So Python, you can do 3D maps, but from what I know, you can only do like in interactive environments. So let's say a web app or a web environment. You can also do that using R. But RayShader, like rendering your own images, that's something Python cannot do at the moment, unless it calls this library from R. But the reason why I put actually this meme here is I do believe that there is no harm in knowing all of these tools or as many as you can. All of them have their own use cases, and I think all of them can help you. If you already have the knowledge of GIS, it can make you even better with that. It can automate your work and make your work more efficient and effective. Whatever you're using in terms of the tool, there are always again some challenges, but with processing the data sets, there are some technical hurdles. So Python is powerful, but even Python sometimes struggles with very large data sets. Running out of memory, processing time, you lack computational power, especially running locally, all this. So you need to understand how actually to optimize your data sets. That's one of the biggest issues I also have with people reaching out to me on YouTube or somewhere else, asking me, "Hey, I spent hours trying to render this map as a 3D map." Well, you actually need to kind of optimize something. Probably you try to render something that was huge. You need to kind of disaggregate your data. There's again problem with data cleaning, harmonization. Again, going back to that problem of having so many different data sources. Which one do you use? How do you integrate them together? So if you're using, for example, Python or R, there are packages that are going to help you with that. There are functions within those packages that can help you with processing properly all these data sets, making them making your workflow more efficient in the process. If you want to create maps, there's always a question, okay, but what kind of map should I create? And I think it really depends on what your objective is. What is that you are trying to communicate? What is that you're trying to achieve? This is obviously a very, very large topic. So here I'm just going to touch upon some basics. But the most important thing is when you're asking what kind of map you want to do is, yeah, in your mind, you have, this is my question, this is what I'm trying to do. And then the second one, okay, given this question or this problem I'm trying to solve, what should I use? Should I use points? So let's say you have events, you would use points. But let's say, for example, you're trying to show population density, then should you use maybe dots, or maybe you should use something else, like maybe I used here 3D map to show the population density of the Netherlands. Also, you always need to take care of the scale and resolution. When I say scale, I mean how much you zoom in and how much you zoom out. Apparently, I mean, if you're trying to map population density for a country, you need to, of course, zoom out. So you are sacrificing detail on your map. And that means you also need to decrease the resolution of the data you're using, because otherwise you're going to end up like that user in the same, I would say, problem, which is you're going to spend 1 hour rendering the map. So there's always some sacrifice you need to make. Of course, if you're trying to show something locally, then you can use a much higher resolution. So you can use a lower scale. And you can easily create the map, but then again, you're losing again the bigger picture. You're focusing on a certain region, but what about something else? And of course, more recently, there is this question of, do I use 2D or 3D maps? This was not really, I would say, a question maybe 10 years ago, but 3D maps have become more and more present. The question I often get, however, is, okay, I work in academia. How do I use 3D maps? Is this something that is going to harm me if, for example, I submit as a part of a, paper for a journal? Because everyone is used to 2D maps, but 3D maps, they might look a bit clunky, they might not show everything. So is it going to harm me? I don't know. I don't have answers to this question. Maybe some of you have answer, but yeah, I don't know what is the best way to answer this. It really depends how you show things. Do you make them clear? Do you use labels? Do you use some other features to really make things stand out? And then there's also the type of interactive maps, which are not really standard in academic research, but they're good if you're sharing with other people. So it's like a small web app that you share with others. So they can also enter there, and they can zoom in, they can zoom out, they maybe can select some details. And of course, the question is also, what is your audience? Is it academic audience or more conservative? Then yeah, maybe you should go for 2D maps. Is it more policy audience? Yeah, maybe you can then, try with some other like interactive maps. Is it the general audience? They love 3D maps, so then maybe you go for 3D maps. Yeah. And then the last one is decision. Yeah, how do I put these different types together? And that's something I also wanted to discuss with you today. How do we put these layers together? And the reason why I'm saying layers is that's the way I actually think about mapping. The way I think about mapping is adding layers one by one, and thinking about how these layers help you answer your question. So for example, here we have this project. So we have this, for example, this forest cover in 2000. So this comes from Global Land Analysis and Discovery, or GLAD. They have amazing resources on the change in forest cover, in urban cover, croplands as well. And this is one of the data sets that they created a long time ago, but they're constantly updating it. So they have information here about forest cover, and they have information, so same data set, but just different values on the tree cover loss between 2001 and 2023. So for example, if you had a project where you were asked, okay, what explains, let's say, what explains tree cover loss? How would I go about it? So, okay, so how would I go about it? First of all, I want to see, okay, what is the forest cover that existed at the beginning of this whole journey? So in GLAD, I find this one, which is, yeah, I have a forest cover, and it tells me what is the percentage for a pixel in my raster that had a forest cover. So I first map that layer. Then the next question is, okay, what is the loss? What is the tree cover loss? You need to make sure that you use basically the data sets that come from the same source. That would be ideal. Sometimes you cannot do that. Then you need to be worried about, how are they measuring tree cover loss versus how this other data set is measuring, forest cover. You need to make sure that there is no discrepancy there in methodology. So that's, a problem you might also face in academia in terms of any other research question. Is my data, compatible? And then even if it's compatible, the question is it resolution? Is it fine? Or I need to kind of upscale, downscale some of this. Anyways, in this case, this is kind of a clear cut. This comes from the same source. So what I do then is I combine these two into this one. And then I have California tree cover, what it was in 2000. And then the next 20 something years, what was actually the tree cover loss. So this would be our, let's say, DV, dependent variable. What is that? So we are trying to explain tree cover loss. How are we going to try it, or how are we going to explain this? Well, the most obvious one is, maybe it's due to fires. So I want to add yet another layer here and understand how fires that happened also in this time span correlate with the tree cover loss. So that's what I do in the next one. So we have this one that we did here. And then I go to NASA firms data. So NASA collects different satellite data, and they also have firms data is on fires, which they capture also using satellites, moving around Earth's orbit. And then they classify based on the signal that is sent from Earth when the satellite issues to it, whether this was whether this was strong enough, or whether it was how would I say, whether it's identified essentially as a fire on Earth. So essentially here in this middle one, we have fires from NASA firms. And then if we combine these two, this one then helps us explain or actually understand if there is some kind of a correlation here between fires and tree cover loss. And again, these fires here, I think I have here 55,000 fire events for the same period. So 2001 to 2023 for California. Of course, in this whole process, you also need to make sure that you sometimes, for example, this data set was for the entire United States. So I had to crop it only for the extent of California. So that's an added complexity. Then I also had to play a bit with the resolution here. Tree cover loss, forest cover did not have the same. So I had to make them the same resolution so that they fit together. And you also maybe notice here, I also have the street view layer, which is the background layer. I just use it to kind of show a context here where this is happening, especially if you're mapping this for localities. And the product of this one is that you can see essentially these black ones that are fires, and they do quite a lot correlate with the tree cover loss that is predicted here. Now, I don't know if the creators of this data set actually use the wildfires to predict the tree cover loss. Maybe they did. So in that case, that would be kind of problematic. But let's say we are naive here and we're just saying, they did not use fires to predict tree cover loss. So I'm just using fires now. Really, they are independent variable here. So I'm trying to understand if there is a correlation here. So that is, for example, one use case. Another use case, which is, I would say, a bit simpler, is adding terrain. So over here, what I have is the population change in Italy between 1990 and 2020. And here I use the global human settlement layer, which I did not present at the beginning, but it's also one of the most important population data sets that exists out there. And it exists for the entire world, so you can also check it out. And what I did actually here is I essentially had one raster file, which is Italy and the population for 1990, Italy and the population for 2020. They were in the same resolution because they came from the same source. And then what I did, I deducted one from another. So what I did get then is whether there was a growth, decline, or no change, or was just simply uninhabited. But what you can see here in this first image is simply, yeah, okay, it does show where things are, happening. But if you add the additional layer here of elevation, you can see, for example, that a lot of these mountainous areas have faced severe depopulation. So essentially, far remote places. So the hypothesis would be far remote places they face more severe depopulation, and if they're of course not urban centers, for example. So elevation or terrain layer gives you a bit more information from which you can maybe derive some additional hypotheses, even test them and see what's going on. So yeah, these are the two, I would say, like very, very simple use cases, but I'm really curious what you think, what would be your maybe use cases for your own area. And then the last one is, from how do we move from the map to the actual storytelling? So what are the, best techniques to translate these patterns and trends into compelling story? I don't work in academia anymore, but I use social media to kind of show some maps and raise some awareness of that. So that's the way I do it. I'm also curious how you do it maybe in your research. What is the way for you to advocate? How would you use maps, for example, to point to some problems in your research to achieve some kind of, I would say, impact? And then what would be the ways that you would do that? What are the aesthetics or layers that you would try to kind of put there? It doesn't matter if you don't have the knowledge of the tools. So just kind of maybe on a conceptual, level, what would be the data that you would use to empower your research or maybe help you answer your research questions? So yeah, that leads me to the last one. I would like here to open the floor for discussion, which is, how would these maps be used to influence decision making? Let's say disaster response, urban planning, environmental research, conflict research, anything that comes to your mind. And also, second, what would be the mapping strategies that you would use in your research project to really, show something or to advocate for something? Yeah, so that would be all. Thanks a lot for your attention.
Great. Thank you so much for the presentation. At least for me, it's super helpful because I'm working with geospatial analytics. I understand that many of the fellows might not be using right now mapping and spatial analytics as their main methods for analysis. However, you found it, all of you found it engaged, and I hope you identified some potential ways that mapping could help you communicate the stories of your research. And before we open up the discussion to all the fellows for the first round of Q&A, I would like to address the main question to you, Milos. It's more about how to get started. What would be your advice for someone that has no background in programming languages or mapping tools? Especially as far as I know, most of the fellows are in humanities or in other fields. Where do you think they should begin with? Looking back to your journey, is there something that you wish you had known or done differently when starting that you think would help someone that is new right now in the field to avoid common pitfalls?
Yeah, thank you. That's an excellent question. I would say I would not do anything differently, but I would recommend to you to start by installing QGIS, which is an open source. ArcGIS Online is not an open source, or it's open to some extent. I would say it's free, but it's not open. QGIS, if you can just go download the latest one and check out some tutorials. So that's something I would recommend that I didn't do. Check more tutorials, try to learn from tutorials. Just check how they are, what are some of the basic steps that you can start doing in QGIS. And what I like to do is start from a problem. So I want to map this. How do I do it? And that's how I learned map making, essentially, by problem solving. Because if you just go into books now or some articles or, YouTube videos and you just like watch, read how others are doing, I'm afraid you're not going to step into action and start using actually to solve something you need to solve.
Great. And then I have a discussion because we are working now with, you have your YouTube channel. And I feel that this is a great tool, a great way to share knowledge and learn from other experts as well. You receive comments from the viewers. And I understand it's a continued learning process for you as well to create the content. How did you continue learning the necessary tools and mapping techniques? Like, what kind of resources you're using? You mentioned this really nice challenge, the 30-day challenge, which is basically a challenge for the whole mapping community. But I would like to hear a bit more in the preparation process for your videos. What other resources you're checking? Or it could be books, could be online tutorials. Any other recommendations?
Yeah, I would go back probably to one of those first slides, and I would definitely say that one of the main sources of inspiration is definitely social media, where people also post their own maps, and they also post, for example, newly available data sets. And then I really want to try those data sets and see what I can make out of them. So that's one. For the 30-day map challenge, I don't really participate, but what I like to do is create maybe more and more tutorials that others can use and recreate maps on their own. And increasingly, I also use a lot ChatGPT to ask about whether some. So I would ask, for example, is there a data set that is available? Can I download it, or is there an R package that can help me download this data? Yeah.
Okay. And also for inspiration, you're using Gen AI, right? You meant.
Yeah, for inspiration, I wouldn't. No, I don't think I'm more using like for kind of trying to brainstorm. Right. But for the inspiration, it's mostly social media. So the contact with really humans.
Okay, sounds good. And then I would like to open up the discussion to fellows. If you have anything you would like to share, any stories on mapping strategies you have applied in your research projects, any experience until now? Any question to Miloš?
I can start. Hi, Miloš. Nice to see you here.
Hey, Olympia.
Yeah, I think it's good opportunity actually to discuss my project because Miloš actually helped me with mine. So just to share an experience, I know Miloš from a long time ago, and I'm fascinated by your work, Miloš. So basically, in my case, Miloš helped me with developing a map for my PhD thesis. I was working on the innovation level across European Union regions. And then I wanted to map out the number of Industry 4.0 hubs or accelerators. So what we did with Miloš is basically we used European Union innovation data to map out the level of innovation of the region and then the number of hubs. I mean, this was done, let's say, as these were two layers of this map, but I think in the future, I would like to see maybe something, a dynamic map actually, so how the data changes over time. So let's say the more of these accelerators emerge, how the innovativeness data changes, but also capturing innovation through different measures like patenting activity or launching new products to market. I mean, this is very specifically my topic, but I just wanted to share this example. And yeah, I think we did a good job with Miloš.
Yeah.
Any difficulties you encountered through that process? Anything to share?
Maybe Miloš can mention the technical aspect of that.
So first of all, hi Olympia, and yeah, it was a pleasure helping you with that one. It was a very straightforward, I would say, because it was mostly about using Eurostat data and then adding an additional layer with the locations. So I would say that it has a great potential to be expanded, and definitely like the time series one would be interesting with the, let's say, the interactive web map where you can use, for example, a filter or a slider. And then by moving the slider, then you can have these different views of how things actually change for these different EU regions or European regions.
I wanted to ask Miloš, actually what I encountered then as a challenge was I wanted to know if this is a frequent issue with mapping the names of the regions, for instance. I know I had a lot of time cleaning the data of NUTS 2 level, and then in some countries the NUTS 2 and NUTS 3 are mixed, or NUTS 1 and NUTS 2 are mixed. So I don't know if you have maybe some comment on that, because I found that very challenging actually, and how much that's also a bottleneck when you work with this data.
Yeah, that's a good question. And unfortunately, there is a problem with the compatibility between the textual, so the tabular NUTS data, and then the maps themselves. So they don't always match. And sometimes there is some missing data over there. That's because the map polygons, they don't usually follow the changes that happen on the tabular levels, or they get updated later. But in R, I think there is a package that helps with that. The problem is, yeah, you then need to know how to code and how to use that. There is a package that helps you harmonize these different NUTS 2 or NUTS 3 IDs that you find in your tabular data with the ones that you find in the polygons.
Mm-hmm. Okay. And in terms of because some over the years, some levels changed actually in some countries. Is there like an API that can actually capture that? Let's say if you have a dynamic data, if you have a dynamic map, would it be able to update?
So I think you would need to make changes before you deploy that to the app. So you would need to, first of all, make sure that you harmonize the tabular data with the polygons before you deploy. And then once you deploy, that already has to be fixed. Now, if something then happens, in a sense, okay, you deploy this workflow, but then in the meantime, again, there is some kind of disharmony. You would need to then again, change that locally, unfortunately.
Okay.
Sounds good. Any other question from the fellows? Any other experience you would like to share with mapping tools? Any idea how to integrate in your current research? Any you would like to address to Miloš? In the meanwhile, I would like to ask you regarding your YouTube channel, what are the main requests from the users, like from the reviewers of your video?
Oh, there are a lot of requests. So they can be very, very specific in a sense. I often now get questions about how do I, let's say, predict land cover classes? So how can I use satellite data to predict? That I still have not tried or started to answer. It is a bit outside of my scope and domain. I have experience with prediction and some supervised machine learning models, but I do think it's a bit context specific. So I don't dare at the moment to venture there. So there's that kind of question. There are also questions about, can you cover this type of map? Can you make a tutorial about this type of map? There's also a question about there's a question about something I covered, but it requires them to think a bit how they could use the tutorial for that purpose. So like how I add the labels, for example, on the map. How do I add roads? What would I use for that? I mean, I covered already that, but sometimes they're asking, the question is more kind of a specific that requires taking tutorial 1, tutorial 2, and actually merging them together. So learning from both and putting things together. People oftentimes want you to give them everything in one place, but that's not always possible.
And are you mostly fascinated with the more technical, let's say, aspect of creating the map, or with the data analysis? Like after you create the map, what we can really get from that? What is the story behind? Like how we combine the different maps? Like what is the most interesting to you in this process?
Mhm.
And because also you have a PhD, you have conducted different kind of analysis for your PhD. Like, was the analytical thinking part the most exciting to you, or like the way, like the initial stages, how you get the data, how you build the database?
Yeah, also a very good question. I think that more and more I like the process of creating it and how I get from the raw data to the map. I used to be excited a lot about data analysis, but I think not so much anymore. Maybe that's because I'm not connected anymore with academia, and I'm not really in those circles or trying to create something that I would influence the decision making. That's why I actually asked the question here about influencing, because I'm not really engaged that much with that. But that also is a kind of a double-edged sword, because if you are sharing also your maps in social media, they sometimes get abused, like used for something totally different.
Right.
Or you also have a lot of hostile comments about something that is I literally did things honestly and presented them honestly, and I used data for that. But comments are so hostile that it sometimes doesn't make any more sense. So I kind of lost this kind of we'll say affection for data analysis. It's more like now about, okay, the process itself. How do I get from the raw data to the actual map?
Yes. Yeah. Any other question? I can continue. I have many, but I would like to open the stage to you. Aida, I see your camera.
Oh, yeah, maybe Peter has his hand raised.
Peter, you can go first then, and then Aida can. You are muted. You need to unmute. Still, no, we cannot hear you.
We don't hear you, Peter.
We don't hear you. Peter, we don't hear you. Yes.
Yeah, is that better? Is that better? Can you hear me now?
Yes.
All right, sorry, I should repeat myself. Right. So firstly, I want to say thank you very much for a very interesting talk. And then to ask about the predictive capacity of these maps. So for example, when you go back to the wildfire example of California, and you show the loss of tree cover, can the mapping is the mapping capable? I mean, I don't know anything about this. I mean, this is why I'm asking. Is it capable of showing let's say future scenarios, or is it would just be a statement about the present in relation to the past?
That goes to the question that I also get often. For example, how do I predict land cover classes? But your question would be, how do I predict tree cover loss? So this would be, I think, the domain of machine learning, where you would try to understand, based on the data you have, data points, whether you can predict something about the future. So definitely you could do that on the ML side. And the maps, you could use the same way I use the existing data. You can also map this future data. So I would say it just belongs to kind of a broader toolkit of geospatial analysis, and not just mapping in this sense.
Thank you very much.
I would like to add there, basically machine learning and deep learning, right? Especially if you are working with satellite data. The deep learning algorithms have huge capabilities for prediction.
Yeah, honestly, I also use data that was produced sometimes because it's open data. For example, Meta's data on tree canopy height is at 1 meter, so it's very, very the resolution is very high. But some people have uncovered in certain parts of the world a lot of errors there. So the problem is, whenever you are trying to predict, there is always some error rates. And of course, it's going to be reported, but sometimes because we're talking about visual things, you cannot really see the extent of error until you zoom in.
Correct. Yeah. And Ida, would you like to go next?
Yeah, thank you very much. This whole topic and method is very interesting. So I'm intervening as a total naive and beginner. I'm a very qualitative person, but I would really like to learn more about it, and I really hope from your suggestions that I will be able to get more into it. Actually, I had to do. I used a little bit some of the maps of the visuals, thanks to my topic of research, that is struggles against hydropower projects in the Balkan region, specifically in Bosnia and Herzegovina and Serbia, for my PhD research. And actually, Bosnian activists they did an amazing work of doing a mapping of these projects. But I think with like very simple tools, like the map is the Google basic map, and sorry, I don't know like technical language, but and then just like with different colors according to like the level. So whether it is a planned hydropower plant or already under construction or constructed. So I was wondering whether you can give some suggestions how we can like enhance, like and put other data or like other way to visualize I don't know, the process of construction, or I don't know, the impact. Do you have any suggestions, inspirations that I can maybe also address to the activists, and we can do this mapping even better?
Yeah, thanks. Thanks for the question. I think that you can do. Again, I think there are tools out there probably that can help you also directly map onto let's say Google Map layer. But if you, for example, really try and do the QGIS tool, you might actually be able to do something very similar, but in a better way than just like, using a Google map and then just putting some dots there. So I would say there are two ways that you could use that. One is for if you just want to kind of show something, like demonstrate or, a descriptive way. So, for example, this is the distribution of these different plant types. A second one, what you could do is, it really depends on your question, but you could, for example, use that for your case selection. So you can use your map to kind of spatially determine what is that you're going to study in a qualitative way. And it's so powerful and effective because you're literally showing visually why you are doing the way you're doing. You're not, using words. You're just using an image. An image is worth more than 1,000 words, right? Or a million words, however it was. But yeah, that's kind of the thing. So you can use maps in different ways. So to show something, just like, yeah, this is what is happening. You can use for the case selection, I believe. You can also use for, some kind of a correlation like I did here. Like you're saying, look, this is the problem. I see maybe it can be explained this way, and I'm going to build my whole research proposal around this. You can do something similar, for example, for the protests or social discontent, whatever you are researching, showing, for example, where protests are, and then saying, yeah, I see here, there is some link. I want to really explore this. So it can be used also kind of to support your research, your proposal, your hypothesis. There is something there that is uncovered, and you should be able to uncover it maybe through your qualitative research. So it's like also a powerful tool for research. In terms of like the policy impact, yeah, I guess, even the simplest map, even though it's a Google map, with some dots, if it sends a very, strong message or something very unexpected, it can garner a lot of attention. I had like some of the simplest maps I didn't put much effort into them, but really, attracting hundreds of thousands of views and, so many comments because they show something very unexpected. So for example, one of them was, what it did was the population density of Egypt, and then overlaid just with the terrain, digital terrain. So then you see, okay, Egypt is flat, but then the population is like a snake just following the Nile, and people were like really going crazy about this. To me, it was like, yeah, nothing special, but just everyone was so astonished. Actually, this is what where 80 million people fit. It just is, along the Nile. So yeah, maps can also have some really unexpected, I would say, can have unexpected impact. If you're showing something that is so unusual to many, many people, but you don't know that until you actually share with others. Because I was also surprised that, the map of Egypt population density would garner so much interest.
Thank you.
Any other question? For this example, for California, the maps that you showed, I was wondering, like, how do you envision that they can influence environmental decisions in the region, in the area, especially in the vulnerable areas with the recent wildfires?
Yeah, I think that we often hear news about. There was a wildfire in California or in Greece, and it's all around the media. But it's a different thing when you hear about some of that, and when you see actually, it's not just that it happened. I don't know, 2017 or 2020 or 2023, more recently in California. Actually, it's been ongoing for a long time, and this is what happens. So you have all these thousands of fire events, and then the consequences are just terrible. California has lost a lot of, a lot of tree cover. So I think, map like this would be kind of a helpful. Maybe if it can be sent to a newspaper or somewhere, so that it can be distributed by other people, or
for people to understand, like the intensity, not only the affected areas, but also the intensity throughout the years.
Yeah, that's also possible. The problem with the years, however, I tried that. You will have values for each year, and then if you choose basically the different color, then it becomes a bit problematic. I also tried to show I tried to show tree cover loss, but kind of maybe put into groups, because we have here 22 years, so maybe group of 7 years, so you have like 3 groups. And then what kind of stood out, which is not shown here, is the last 7 years have been very devastating. Like a lot of fires in the last 7 years, which could maybe then, that brings me back here. Maybe it's not just fire. Maybe there is something even before fire, which is kind of a drought, for example, lack of precipitation, like low precipitation, could also be something that could be overlaid. So the impact also of climate, for example, climate variables on this.
Yeah, that's super useful. I know we are over time, Irena, right?
Yeah, we still have 11 minutes, so
if you have any last question, feel free.
If you have any last question,
do this. Yeah.
Well, maybe I can, Miloš, I can ask you about like climate risk data. So I've been engaged in some projects with the banking sector. So there is a lot of work being done actually on that front, like trying to assess climate risk by exact geolocation or like a radius. So I don't know if you have had any experience with that. I see big push that banks themselves start using or have almost like a data scientist that will predict and follow climate risks all the time so they can manage their portfolios better. I'm just wondering how reliable these data are and how how much they change actually over time. When we provide, for instance, a bank with a data on these are the climate hazards by this exact location, how much this probabilities of these risks happening are changing actually. So maybe if you have some experience with that, I would be happy to hear.
Yeah, that is, I think, the question of how accurate or how precise are the findings in a data set, and then this varies a lot. But there are some which are very reliable, highly reliable, and one of them, for example, that I would recommend is the European, so the CDS. I don't remember now what was the Climate Data Service, CDS, Climate Data Service. So that is the European one, but it has global coverage and includes a lot of different variables, climate variables. There's, of course, NASA as well, which is also has a global coverage. Those are the ones I would say that are golden standard. But recently, Google has launched their own climate data service, which is based, I think, on deep learning, if I'm not mistaken. And in terms of the accuracy, they claim that they are very close to the CDS or maybe even overpassing CDS. But I would say the golden standard is at the moment the European CDS and the NASA climate data. And that's something that I would really recommend. If also data scientists, if they're using the data to predict something, they can use actually the CDS data, which already has predictions, I think, until 2100 or something like, I don't know, something similar. So they're already like predictions, they can be already used. And these models have, proved to be quite accurate based on the, past data, past experience.
Okay. Thank you.
So any last question, maybe? I don't know if Eleni is back. Okay, yeah, you are. But we don't hear you, Eleni. No.
Yes.
Yes, we do. We can hear you now.
Yeah, if there's no other question, I would like to thank Miloš for the great presentation. Thank you for being today with us. We really appreciate it, your time, and hope to see you again.
Thank you for the invite. And yeah, best of luck to everyone. And if you have any questions, feel free to reach out to me on these different social media and
YouTube channel. Yeah, feel free to share actually more future tutorials.
Yeah, and once this recording of this presentation is on YouTube, I'll be happy to send you a link so you can also pass it forward to anyone who is interested. And also you will guys have it online as well. And yeah, thank you so much for being with us from my side as well. And yeah, I enjoyed this presentation a lot, even though I know nothing about this, but I was very curious, and yeah, it's very interesting what can be done.
Thank you.
Have a good evening, Cody. Bye. Bye, everyone.
See you next week, guys.
See you.
Bye.